There's the record button. So, problem number 2. A grocery store purchased melons from two distributors, J and K. Distributor J provides melons from organic farms. The distribution of diameters of the melons from distributor J is approximately normal, with a mean of 133 millimeters and a standard deviation of 5. For melons selected at random from distributor J, what's the probability that the melon will have a diameter greater than 137? So they told me it was normally distributed. I have a mean of 133. They want to know the probability that it's 137 or greater. All right? So this is just a typical normal question. So stat test, z-test, not the only way to do it, but I'm going to cheat and do it that way. And we have 133 for our mean, our standard deviation of 5, an x of 137, and we're looking for just one melon, so our sample size 1, greater than, and then we're going to calculate, and we end up getting 0.2119. So there's about 21% chance that if we randomly select a melon from distributor J, that it'll have a diameter of at least 137 millimeters. All right. So distributor K provides melons from non-organic farms. The probability is 0.8413 that a melon selected at random from distributor K will have a diameter greater than 137 millimeters. Please note, they didn't say that the melons from distributor K were normal, so we can't use the same, we can't use the claims that we did for J. We can't use the normal distribution here. So for all the melons at the grocery store, 70% of the melons are provided by distributor J and 30% provided by distributor K. Great. So with that said, it's like, you know what? I know a couple things. I have melons that are less than 137 millimeters, melons that are more than 137 millimeters, and I also have distributor J and distributor K. So I have essentially information to make a two-way table. So that's what I'm going to do. As it turns out, since they gave me the percentages, and it's like, hey, 70% from J, 30% from K, that makes it easy. So I'm going to start with those. Distributor J is 70%, distributor K is 30%, that sums to one whole. And I'm immediately going to bring up that 70%, and I'm going to say, you know what? Those are the first things I'm going to write down. That's the first thing I'm going to write down is I'm going to bring those numbers, but just copy them up. Here, I'm just going to bring those 30% up. That's the very first thing I'll do with K. Now, I should have said already that I have melons greater than 137 and melons that are less than 137. All right, so with distributor J, I know that 21% of the melons are greater than 137. So 0.7 times 0.2119 gives me this. 1 minus that, and I multiply by this, gives me 0.55167. And I can check it by adding these two values together to see if they equal 0.7. Fortunately, they do, so I've done that part right. They told me the probability from a K is 0.8413, so I just write that here, and 30% of them come from K, so 30% times this gives me this. And this is just 1 minus that. Multiply those, and when I add these two as my check, they also sum to 0.30. If I sum across, I get 0.40072. Sum across, I get 0.59928. Add these up. They should also sum to, and they sum to 1. So please remember, this plus this equals that. This plus this equals that. All right? So either direction you go, it should sum, the rows and columns should sum together. All right, so for a melon selected at random from the grocery store, what's the probability that it'll have a diameter greater than 137? Well, that all of a sudden, that problem became fairly easy because the greater than 137 is right here, and it's 0.40072. You've shown your work, just label it, and you're good to go. Then we have the given problem. Given that a melon selected at random from the grocery store has a diameter greater than 137, so we're basically saying out of the group that is greater than 137, that's my given, what is the probability that it will be from distributor J? So probability of A given B is intersection over given, which in this case is 0.1483 out of the 0.40072. And that's my answer. All right. Is a melon diameter greater than 137 and distributor independent? And I really wanted to say in distributor J independent, and I didn't put the J in there. Justify your response. Well, if things are independent, you had a couple ways to work this problem, and I went with the multiplication rule just because I think it's easier. So I went A intersect B equals A times B. All right, well, my intersection is 0.14833. And they said it had to be greater than 137, so this is 0.40072, that's the probability of that. And if I made a distributor J, this would be 0.7. So this times this needed to equal that. When I multiply them together, they're not independent. I mean, they're not equal, therefore they're not independent. Please don't stop there. You need to make the statement that they either say they are independent or say that they are not independent. You need to show your work for that. What's the probability that a randomly selected melon is greater than 137 or comes from distributor J? All right, the key word there is or. That tells me I'm working with a union, which means I'm using the addition principle. So probability of A union B equals the probability of A plus the probability of B minus the intersection. So in this case, they said greater than 137 or from J. Well, greater than 137 is 0.4072. J is 0.7. So this plus this, but minus the intersection. And my intersection was 0.14833. When I add those up and subtract, I get 0.95239. Please make sure that you never have a probability greater than 1 on your paper. Chances are you either made an error or you wrote down the z-score, but please don't have a probability greater than 1. Graders don't like it. They count off big time. So I just copied the table over since we're going to be referring to it. So what's the probability that a randomly selected melon from distributor J has a diameter greater than 139 millimeters? Well, we already did the one with 137. This is kind of just a repeat of that problem, but when we change the size. So we're still working with a 133, but now my melon I need is 139. So stat test, z-test, 133, standard deviation's 5, 139. We're still looking for a single melon. We want greater than, we calculate, and we're good to go and say, all right, z is 1.2, and we end up with that probability of 0.1151. The next one says, what is the probability that 3 melons randomly selected from distributor J have a mean diameter greater than 139? So now we're looking at the mean diameter, and we have not just 1, but 3. So consequently, we're working with this formula, all right? So that's very easy again, stat test, z-test. Everything's the same, except now I need to adjust my sample size to size 3. And we find out that this is substantially more, it's certainly rarer that this would happen. So our z-score is 2.078, and the probability of it happening is a little less than 2%. So there's about 2% chance that you would get 3 melons from distributor J with a greater than 139 diameter. The next one, what's the probability that in a group of 10 randomly selected melons from distributor J, at least one has a diameter greater than 139? Well, there's a whole lot of interesting things here. First off, we have a fixed number, and we look for at least one. As soon as I think at least one, I always go 1 minus. I also know that I have, okay, I could have 0, 1, 2, 3, all the way to 10. This is what I'm interested in. And because I have a fixed number of trials and I know the probability of 139 because I just calculated that, probability is 0.0188. What's the probability that, so I need to do a binomial, and I need to do a PDF of this plus this plus this plus this, or because it's at least, that means I can use the 1 minus principle. So I can do the 1 minus the probability of 0. Because it's a binomial, I need to make sure I write down my formula. And I can show it at one of two ways, the PDF of 1 all the way to the PDF of 10, so including the lowest, highest, and book in between. Or what I prefer to do in this particular case is, since I know since I know that I'm going to do this in the calculator, I'm going to do 1 minus the probability of 0. I wrote this down wrong. Sorry, this should have been 0.1151 because this comes from the first problem. So that needs to be 0.1151. So here we go. 1 minus second vars binomial CDF. And once again, it's a CDF because I'm interested in more than one value. So if you always just sit there and go, you know what, if you're interested in more than one, use a CDF. Trials are 10. P-value 0.1151. X value, in this case, is 0. And there's almost a 71% chance that among 10 melons, at least one will have a diameter of greater than 139. The next one, what's the probability that at least 3 melons in a group of 10? So now we want the probability that X is greater than 3. So I'm interested in these values. We know from above the probability of being great for a single melon to be greater. Single melon probability is 0.1151. Once again, our probability is fixed. We have a fixed number of trials, so it's a binomial. We write our binomial formula down, and we can do the PDF all the way up, which would be 3 plus and then bookend, so the lowest and the highest. But because it's an at least problem, I'm going to know that for the calculator purposes, I'm going to need to do 1 minus the highest value I don't want. The highest value I don't want is 2. So 1 minus the probability of 2. So in this case, 1 minus, and then I put in my lowest and highest in the range that I don't want. Should have been a bracket here. So 1 minus second vars binomial CDF, because it's more than one value. But the trials is 10, the probability remains the same. The highest number I didn't want happens to be a 2. So I subtract that out. And there's less than a 10% chance, but almost a 10% chance that in a group of 10 melons, I would have 3 that were greater than 139. So about almost 10%. All right. What is the probability that the first melon randomly selected from J with a diameter greater than 137 is the third melon selected? Well, first off, I want to tell you where I get this 0.2119 from. because first off, we're talking about greater than a 137. The previous problems were greater than 139. However, on the first page, our very first problem, part A, we said, what's the probability that greater than 137? So this is 0.2119. So that came from the very first page. Here they use the word first. All right. First melon randomly selected from group J with a diameter greater than 137. As soon as they say first, I think geometric. And in this case, I'm going to need a fail on the first, a fail on the second, then a success on the third. So here's my success. These represent my failures. On a calculator, I can, because I'm looking for a specific value, one specific value, this makes it a geometric PDF. So second vars, geometric PDF, 0.2119, x value of 3. So there's about a 13% chance that among that the first melon that is greater than 137 is the third melon selected. Part K. What's the probability that the first melon randomly selected from distributor J with the diameter greater than 137 is among the first 3? And I didn't make a number line, which is a shame. That means it could have been the first one, it could have been the second one, it could have been the third one. So one of these, I don't care which one, has to be the right size. So it could have been the first one. Well, the probability of success on the first one is 0.219. The probability on the second, so this would be the second success, would be fail on the first, and then second. Then for the third, I need a fail, and then a success on the third. So my probability, second vars, geometric, CDF, 0.2119, x value, 3. And it was a CDF because we had more than one value. Anytime you have more than one successes, could have been on the first or second or third, it's going to be a CDF. And finally, what's the probability that the first, once again, first, randomly selected melon from J with a diameter greater than 137 does not occur among the first 3? That means the first one was going to occur on the 4th, 5th, or 6th. We're looking for this probability. So it doesn't occur among here. So I want this, I said that wrong. I want 4, 5, 6 all the way to infinity, but I can't do the PDF of infinity. I can't, so basically I have to do 1 minus because I want greater than. So that's 1 minus the probability less than 3. So this will be my work shown. So probability of success on the first one, fail, success on the second, a fail, then a success on the third. So I'm going to do this 2 different ways. 1 minus second vars, geometric CDF, and we get 0.4895. Now, someone probably recognized, hey, we had already calculated that probability in the first one, in part K. So 1 minus the probability of it happening in the first 3 would also give me the same answer. If you recognize this, you would need to say from K above. The only problem is if K is wrong, then I will be wrong too. So that's the only problem with doing that. All right. So there's a 48.9% chance that the first melon is greater than 137 is not coming from the first 3 melons selected.